Hi everyone. In this devlog, we will be talking about something most of you know nothing about. The world subsystem. How it can be used to manage in-game resources and respawning them. The world subsystem is a very powerful tool for game developers. So you ask, Yo Jim, why is this world subsystem so important? Well my friend, when it comes to managing game elements like resources, weapons, or enemies, having a centralized system makes it way easier to keep track of what's happening in your game world. With the world subsystem, you can keep track of all the resources in your game, as well as control when and how they are spawned. So, in this devlog, we are going to be diving into the world subsystem in Unreal Engine C++, and I will show you how it can be used to manage game resourcing and respawning. But first, this is Jim, the indie dev guy. Today, I'm taking you on a journey in my devlog series. If you missed any episodes, here is the link for the entire thing. I want to show you the entire development process, and I'm hoping you can give me lots of valuable feedbacks. Can't wait to hear your thoughts, and don't forget to like and subscribe. It really helps a lot. Thank you in advance, and let's go. So, first things, let's create a new class for the world subsystem. Okay, so new class or classes, world subsystem. So I'm gonna choose world subsystem here. Next, and I'm gonna call it main world subsystem. Yes, thank you. And I have to add that at the end. Okay, so the class compiled. I just added these few includes here and made the main world subsystem. So it have a constructor, an initialize and deinitialize. So I went on and implemented these functions. Right now it does nothing, just like print a log message the subsystem created, initialized and deinitialized. I went ahead and clicked compile and it like perfect. So I don't even need to specify it or anything, just like click play and it's already defined in the game. So whenever I click play, oh well, look at that. If you look here, I got the first warning, the world subsystem created and the initialized. And I don't see any like world subsystem deinitialized. Yes, of course, we will never see that because it's on the deinitialize function. But if we stop the game like right now, we shall see that in the output log here. So exactly, world subsystem deinitialized. So this is the first step of making this whole system work. So what I'm gonna be trying to do right now is like for example this rock, it's spawned here. So I'll set on the actual actor itself, which is like not this one, but the actual actor. Yeah, that's like the main defaults for this actor. I'm gonna add spawn timer, okay, or respawn timer. So whenever this thing is destroyed, it will just tell the world subsystem, okay, I got destroyed and this is my respawn time. So the world subsystem at this point shall know exactly that this object, like the one you see here, is destroyed now. And this actually will be saved. So whenever the game relaunches, the world subsystem knows that okay, that actor is destroyed. So it will go ahead when the game is loading and destroy it again. Okay. Yeah, and once it's like destroyed and the timer runs out, it will like respawn it again. So now players cannot just like keep spamming this system and destroying or mining the entire map worth of resources, and then just like close the game, go back in. Okay, you have all the resources again. So yeah, let's see how can we implement that. Okay, so the first thing I did, I opened up the mineable actor header file and added this little tiny new property here as a float that just hold the respawn time, and I set it for like default to be 5 seconds just for testing purposes. And then yeah, I went on, and instead of like destroy when the health is less than 0, we drop the item and then get the world subsystem. This is how you get a world subsystem, by the way. You get the world and get subsystem, just like, and specify the class of the subsystem. This is saved into a pointer, like we don't need to explain that. So if this returns valid, and just like ask the subsystem to respawn this actor and destroy itself, and destroy it. So I made this little function in the wallet subsystem that is like stating respawn mineable actor in a specific time. So I give it the actor respawn time, and I give it like this class itself, so it does know what to respawn when that specific time comes. So jumping to the world subsystem, I made this like game time as a like int64, like default to 0. Of course this will be saved, and we made like a list of if actor to spawn. Okay, this is a struct that's like holds this specific data, which is like the actual actor to spawn, the location, rotation, and the respawn time. And then this is the function we discussed earlier, like it's like spawn an actor in a time, and this is the actor. And then I went ahead and in the initialized, I made like this timer, only one timer for this entire thing. It calls the function called the time manager, which is like this thing. What this time manager does is it ticks once every second, so it does not tick every frame, which is like, this is very, very nice for the computer. It does not take a lot of performance or any measurable performance anyway, so it ticks once per second. It can even be set to tick in slower rates, but just for like testing purposes, I made it to tick at least once a second, and loops. So this function gets called, which is the time manager. So it increment the time by 1, okay, and then check the actors to spawn array, the T array. If it's like if it has any actors, it loops through them, and if the actor respawn time is less than or equal the game time, spawn this actor in this in the actor in the saved location and rotation, and then remove itself from the array. Okay, so every time the game ticks, it checks like for all the actors. We can of course make this break when it gets like way higher than the game time. So how does actually the actor get inside this array? Okay, when it gets destroyed, as we saw in the last one, it calls this function, which is like respawn mineable actor. So this is the function itself. It creates a new actor to spawn and set the class to this class, and the location to the actor that came in with the function location, and so is the rotation. For the spawn time, I get the current game time and add to it the respawn time that came with the actor. So the game time now is 10, and the actor is set to respawn in like 5 seconds. So it's gonna be in 15-second mark. This is the respawn time, okay? Yeah, of course I check if the array is empty, just add it and destroy the actor that came in. If it's not empty, I insert this actor into its correct position. So as we said, it's not gonna be just like adding in the bottom of the array, like keep piling. No. If the first actor is like set to be like spawned in second number 1, and the second one is second number 10, and the new actor is 5, so it will keep checking. Okay, I am way more than 1. I'll go like down 1 step. Okay, the one next is like 10, so okay, this is my actual level, so I'm gonna stay here. So it knows its order, so we don't have to like loop through the entire array. Just like go from the top, you will find like the first one, always the first one, or the first few, if like happened by any chance to if you get destroyed on the same second, which is like highly unlikely unless you're like in a very high density multiplayer game. But let's just like say for it now, it loops through the entire thing, and it goes like from the top to the bottom, and the new actors get inserted on top depending on how much respawn time they have, and then of course respawn and return. So let's actually see this happening in action. If I just like press play here, I got my trusty mining gun, and I'm gonna kill this, and through the magic of editing I will be on the point where it actually breaks. Okay, there it goes. It just broke, and we wait now for 5 seconds have passed and the actor actually respawned in 5 seconds. If we like open the output log here and clear it, destroy again, edit, we will see that the actor will get called in 5 ticks exactly. Okay, 1, 2, 3, 4, 5, 6, yeah, so it's exactly okay. So that works. I think now what we should do is actually I've placed these manually using procedural foliage generator, but I don't want that. I want to actually make them spawn, like literally spawn. Oh yeah, and one other thing, when the game I want to be saving this array, okay, this one, so whenever a player comes back to the game, the game time and this array are saved, and it loops through this array and destroy each of these actors so you don't find them in the seed. Anyway, yeah, so let's see what we do next. So after so many crashes, this is what I have reached. So I made like a very simple function to save the game. Okay, I'm just passing to this function the actors to spawn and the game time as we discussed, and when it like succeed, it says like save successful, and you get the point. And also I made like this little tiny load function. It loads the game and also get the same exact data, like the actors to spawn and the game time. And when it succeeds, it starts calling this function, which is like remove mined actors. Okay, this function, what it does, it loops through the entire actors to spawn and compares actor in the world ID with actor to spawn the IDs. Okay, and if the ID matches, this actor gets destroyed before you even see it. So I went ahead and added this string ID here to each mineable actor and set it up very efficiently, like very easily in the constructor. If there is no ID, like set up a new ID, and all you need to do is like literally save the game, and that literally should do it. I went in. Yep, see? Okay, so I stop the game now. So when I start the game, I should not see this rock in front of me. And let's see. Yep, it's gone. All the other rocks are like there, except this one. And after 10 seconds, it got like reloaded back again. Okay, so yeah. That works. Right now what I need to also do, like maybe like the next time, is save how much resources have I mined from this node and from any node using the same ID thingy here. So you see this health. So I'm gonna save this health in another array, only the mined assets array, so it will not hold all of them. It will only hold the modified to make it like smaller and maybe like more efficient. Yeah, so and this will like save literally how much resources you have mined from each node, and also how like literally save what's inside the player inventory here. Yeah, and that literally paved the road for us to add those trees and the wood on the ground and any other type of mineable resource into the system as well. So yeah, that should do it for this time, and please do not forget to like and subscribe, and you can join the Discord server.